Hey guys, I'm Matt, a developer from Ohio, and in this video I'll be walking you through the bank account project. To complete this project, you'll need to be familiar with classes, data structures, and control flow. Let's get started. In this project, we'll create a Python class that can be used to create and manipulate a bank account. The class will have functionality for creating an account, displaying an account, and handling deposits and withdrawals. Make sure you're regularly saving and running your program. Not only do you risk losing work if you don't save, but it will be a lot easier to fix bugs and typos every few tasks, instead of all at the end. We'll start by creating a bank account class. This class should inherit from object. We'll write class bank account, and in parentheses here, we'll write object so that it inherits from object. To represent the money stored in the bank account, we'll add a member variable called balance and start it at 0. So balance equals 0. We'll define the initialization method, also known as a constructor, using the default self parameter, which will refer to the bank account itself, and an additional name parameter, which will refer to the account's owner. So I'll drop down here and define init, short for initialize, and in the parentheses here, we'll put in self and name. The name parameter is just an input, which exists exclusively in the scope of this method. To save the name to our object, we'll have to assign name to self.name. That looks like self.name equals name. Next, we'll define the representation method, which looks like init but uses the letters repr. We'll pass in the default self parameter. So outside of our initialization method, I'll define repr and pass in self. The return value of our representation method will be the string that gets outputted if we print a bank account object. We'll use string formatting to return a message stating the account's owner and the account's balance. We want to make sure that the balance is shown with 2 decimal places because that's how dollar amounts are typically displayed. So inside of this method, we'll return a string, and we'll say something like one string here for name. Name's account has a balance of, and then I'll use a $sign followed by the parenthesis symbol, 0.2 to represent 2 decimal places, and F for float. And I'll use the percent symbol to attach some strings, and we'll attach self.name and self.balance. If we want to show just the balance, we'll need a separate method. We'll create a showBalance method that once again includes the default self parameter. So we'll define showBalance, and that includes self. And inside the method, we'll print out just the balance, using string formatting to ensure that it's displayed to 2 decimal places. So here we'll print the string that says total balance is, and we're going to format this just like we did above. We'll use a $sign and then a parenthesis sign, 0.2, F for float, and then we're going to attach self.balance. Now that we can initialize and display our object, we can add some functionality. We'll start with a deposit method, which will add money to the bank account. This method should take the default self parameter and an additional amount parameter, which is going to be how much we deposit. So we'll define deposit with self and amount. If the user tries to deposit $0 or some negative amount, well, that's not really a deposit. We'll do withdrawals later. We'll add an if statement to check for 0 or fewer dollars, then print out an error message if it is. We'll also use the return keyword to exit the method. So if amount is less than or equal to 0, then we'll print out a message like deposit needs to be a positive amount. And then we'll return to exit from our method. We'll add an else block to handle amounts that don't cause an error. Inside the else block, we can print a message confirming the action. Once again, we'll use string formatting to make sure that the dollar amount has 2 decimal places. So else will print out depositing, and then our string, which looks the same as all the others, and we will attach amount. Now that we've said we would, we should actually add the amount to the user's balance. We'll add amount to self.balance. That's self.balance plus equals amount. Earlier, we created a showBalance method to display just the balance. We use that now to confirm the new amount. Remember that showBalance requires a self parameter, so it needs to be called on an object. To call a method on an object, we use dot notation, just like with our variables. So we'll call self.showBalance. Now we can move on to withdrawals. Just like with deposits, we'll define a new method with parameters self and amount. I'm going to go ahead and minimize our other methods since we're done working on them. Now, I'll come in here, below our deposit, and I'll define a withdrawal method with self and amount. We can do some error checking in our withdrawal method, just like in our deposit method. One valid input would be an amount higher than the amount saved in the account balance. You can't withdraw more money than you have, so we'll use an if statement to check if amount is greater than balance. If it is, we'll print a message and use return to exit out of the withdrawal process. So if amount is greater than self.balance, then we'll print out a message, not enough money in account, then we'll just exit using a return. In an else block, we'll handle valid withdrawals. We should print a message confirming the action just like we did in task 11 for deposits. So else, we'll print withdrawing, and then our string, formatted just like all the others, and the amount is amount. Once again, we'll follow up on our promise by actually subtracting this amount from self.balance. So self.balance minus equals amount. To finish our withdrawal function, we'll use showBalance on self, so the user knows how much money is left in the account. Self.showBalance. Now that our bank account class has functionality for creating, depositing, and withdrawing, we can make a new account to test it out. Outside of the class, we'll create a myAccount variable set to a new instance of bank account. You can use whatever name you like for the parameter. This will just be the name of the owner of the account. So again, I'm going to minimize these because we're done working on them. And below, all the way to the left, I'm going to create our myAccount variable and set that to a new instance of bank account. And I'm just going to set that to have my name as the owner. Earlier, we created a representation method, REPR, for our class. We can put this into action by using print on myAccount. Let's try that now. So we'll just print myAccount. To clarify the difference between representation and showBalance, we'll use our showBalance method on the next line. We'll use dot notation to attribute the method to our myAccount instance. So that's myAccount showBalance. If you run your program now, you can see the difference between representation and showBalance. The first line will be the representation method with print, and the second line will be the myAccount.showBalance. To test our deposit method, we'll deposit $2,000. myAccount.deposit 2,000, and this is just using the deposit method that we defined earlier. To test our withdrawal method, we'll withdraw $1,000, which is the same, just with withdrawal instead of deposit. To finish our program, we'll print myAccount one more time to see the final representation of our object. So that's just print myAccount. Let's check our output. You can do that by typing in Python bankaccount.py, then hitting enter. If you haven't been regularly saving and running your code, you might need to fix some errors before getting anything to show up here. If everything is working fine, you'll see the bank account's initial information, the balance, a deposit, the balance again, a withdrawal, the balance a third time, and then the bank account's most recent information. In this project, we created a Python class that represents a bank account. We added the functionality to create an account, display an account, and make deposits and withdrawals. We also added an instance of our class to test this functionality. Classes allow us to create and organize templates for our objects. This pattern is essential to object-oriented programming, which is the most dominant programming paradigm out there. I'm Matt for Codecademy. Happy coding!